Actually, we're recording. Hello, all.
Hello.
I think we're
Hello.
recording. Once again, we're
up.
dinking with the software. Hello, YouTube.
YouTube.
Hey, Ben, how are you doing today?
I'm all the better for seeing you, my friend. It's good to see you again.
Nice. Good comeback. Good comeback. I like it. So, well, we got a show today, though. You're going to, amongst the other things, we asked the people in our Discord channel, and we have a Discord channel called Coriolis-Effect. No, it's just called Coriolis Effect. And then we have a website, Coriolis-Effect.com.
And you'll find the invite link to the Discord channel on the website.
That's right. So, and we asked our Discord people what would they like to see today, and one of the answers was low-cost lab equipment. And so you've got some low-cost lab equipment to show us, and then I don't really have a camera set up to point to mine. Maybe we can do that on a different day. I thought we'd see what you have going today.
Here's what I'm going to do. I'm going to take my phone out because the image quality is far better than this ridiculous, excuse me, webcam. Just give me 1 second because it'll enable me to prop this thing up. So I need my webcam app. Where is it?
So somebody's just commented that they can finally see the live show again. So
cool.
That's
okay. Cool. So I didn't get to post the link to LinkedIn yet, but maybe I'll do it afterwards. Okay. Now, Irian webcam, where are you? Here it is.
So while you're doing that, I can describe kind of some of what, you know, when we talk about lab equipment, as an engineer, I could never have done hardware engineering at home back when I first started, just because a single scope was more than I made in a year, you know, as far as cost. And then came eBay. And that's where my junk behind me came, is just by knowing the pieces of equipment that I liked, and by brand and by model. You know, I'm a Tektronix fan for scopes. Anything where I'm looking at the signal, I use Tektronix. However, when it comes to generating the signal, I tended to use HP. And so behind me are several HP signal generators, where they're RF generators, audio generators, that kind of thing. So that's what drove my decision-making process. And you know, my equipment typically costs $100 each, something like that. I was getting good scopes, analog scopes, which I no longer, they just were taking up too much room around here. I was getting them for between 100 and 200. But again, I knew what I was looking for before I went looking for it.
Yeah, that's right. Step one is, you know, watch a few videos actually, because there's a lot of people out there who get old test equipment or used test equipment that may only be, you know, it could be like 10 years old or whatever, but for 99% of what you do in electronics, you know, what kind of bandwidth would you say you need, Bill? If you're using an oscilloscope, you're usually measuring what? You're measuring analog stuff,
right?
Like that. Outputs of filters, or, you know, level shifters, or analog amplifier type things. And
everything your voltmeter can't show you. If something's going on and off, and you want to see the on and off part, not just on or off, you need a scope.
Right. And so there's that. And then there's, as far as digital goes, you want to get a logic analyzer as well. And most digital circuits, most of the time, you know, it's different if you're designing a system on chip with DDR memory, and you're going, you know, you have a 800 megahertz clock or a 1600 megahertz clock. You know, now you're dealing with super high speed stuff. You need a very high bandwidth, expensive scope. Most of the people designing that kind of digital electronics, if you know what it is you're designing, if you know about the signaling and how to design a board with good signal integrity, you don't need a scope to measure it. And in fact, putting a scope probe on some of those traces actually
changes what you're measuring.
it caused the probe effect. You're putting a branch on it with another transmission line and load, and that entirely ruins everything. So even the companies that, I go to trade shows like DesignCon in Santa Clara, and you'll see really big, expensive oscilloscopes. That's like oscilloscope heaven, that trade show.
Right.
And they'll be showing the latest generation DDR5 or PCIe, and showing how their scope is actually able to help people engineer the latest standards, which are still being worked on. And and they'll show, fancy PAM4 eye diagrams and all sorts of stuff. And it's impressive that you realize they've got a lot of technology to get into basically a chip, and what they're really trying to measure is what's happening at the die bond, where the silicon is connecting to the lead frame, basically, or the lead frame is normally made of PCB material. But and apart from that, they're also pushing these signals through test coupons. So at that level, you don't measure the actual thing that you're prototyping. What you're measuring is a piece of circuit board called a test coupon that is representative of the other transmission lines you've designed into your project. So you design your board, you've got a board like this one, right?
Right.
And
is that a Mach board by any chance?
This is a Mach X02.
It looks like one, yeah.
Board. Yep.
Yeah.
I love this thing. I couldn't believe how cheap FPGAs are from Lattice. They're just wonderful. So you have a board that you design, and what you do is you design the layer stack up for signal integrity. So you've got plane layers and signal layers, and you plan your impedances, and you can know how length matching is going to be done and all of that, and you plan your via structures so when you change layers, it's not too much of an impedance anomaly.
Right.
Now you can measure all that with an actual TDR if you have a really good expensive one, right? And you don't, if you buy one secondhand like the one that you got and that Mike Fikes has, you can actually get a really good TDR for pennies on the dollar what it originally
They're just
cost.
old, is all. Yeah, they don't have niceties like Ethernet and stuff like that.
Right. But what is normally the process is next to your actual board design on the same panel from the same manufacturer that makes the board. So if you go into Osh Park, you would have to design this and say this has to be on the same panel, because you want to measure the effects of the lamination of that panel. So,
right.
So next to it, you have another little piece of board that's just a sample that has a test point here and a test point here and transmission lines in between of the different, you may have differential pair if you're doing USB or several pairs, and you may have some via transitions to test what the via transitions do, and then they snap that off and give it to you, and you measure that with a TDR. So that's how that's done once you go beyond, a couple hundred megahertz. But what would you guess? I mean, I have my own thoughts on this, but Bill, as an experienced designer,
it kind of depends what you're working on. But if for a beginner, I'd say 100 megahertz is a good corner to use.
Yep.
Back in the day when I was starting, I used a 250 meg was my holy grail. But these days, if you're looking at I/O lines and the lines you'll see on an ESP32, those kind of things, the stuff that comes out of these chips, these modules, 100 meg is very serviceable, including the little handheld units.
Yes, which brings me to what I wanted to show off today.
So what I will say, though, is the last analog scope I had, I searched around for it. I had gotten a Tektronix 2465B, and it was like 400 megahertz, 450, something like that. But for what I was doing, I wasn't really seeing the additional bandwidth in the scope. Whoops, we just lost you. You just went blue.
No, I'm switching to Webcam.
So while you're doing that, I'll say that Wes said I had given him a Tektronix 1241 logic analyzer, and he's saying it's working well for him. So that's one of those things where if you know what to look for on eBay, you can get really good deals.
So
Mike is telling us that that the TDR he got with the head and stuff you can get for around 500. So, yep. And somebody else mentioned that they don't use the Ethernet, which I use the Ethernet on my scope because of, the fact I make videos. So I need to share it with somebody. I'd be perfectly, well, that's not true. I've sat upstairs and debugged my entire installation sitting on the bench behind me by being RDP'd to the computer that's part of my workbench and then looking at the scope output. So I've sat there and manipulated outputs and looked at it on the scope. So let's see, what else can I talk about while you're
I don't know what's
there?
going on. So I switched back to the XSplit Vcam.
Dude, stop your share and start your share again.
I didn't share anything yet.
Yeah, you're not sharing. Yeah, that doesn't make sense.
Gosh, in the words of Goofy.
So I'll go ahead and ask everybody what bandwidth scopes do they have? Does anybody have the little handheld scopes, especially? There you go. I see your VCam.
I know.
You're getting
I
closer.
realize I have to. Skype has a bug, so I have to stop sharing the camera and then start it again.
And that's what I meant by stop and start. Yeah.
Right. So let me just switch real quick. It should work this time. I apologize, everyone.
Not a problem.
I'm going to switch back.
So somebody asked what's on the wall behind you. Is there a simple phrase you can say, the glowing sign?
Oh, yeah. I was going to try and get this camera to focus on it, but I can probably do that better with my phone. So I'm going to switch over to my phone and try to show you. It's an LED panel that I made.
What is
recently.
the Buffy Project? Can Do is saying good afternoon from the Buffy Project. So Wes is saying he's got a 200 megahertz digital and 100 megahertz analog. So Wes, I'll say the part of the equation between digital and analog, though, is then your sampling time. So when you say 200 megahertz, I use my next question is at what sample rate? And I typically see I don't want to say a sample rate of 5:1, but it's usually much higher than the analog sample rate. Somebody else has a 200 megahertz, says Siglent, but I thought it said Digilant, 4-channel, about 750.
Not bad. Not bad. And Handtech, I've noticed, so I can't vouch for how high quality they are because I haven't used one, but there appear to be a lot of Handtechs on AliExpress that some are like 4-channel 500 megahertz, which is really amazing for
that would be
a few hundred, like $400 or $500. It's crazy. So but
looks like somebody else has a Siglent.
I remember being a student in college, and there was this one textbook I had to buy that was like $180, and I just felt literally nauseous at the prospect of having to spend, because I was working 1 day a week at a power supply factory soldering boards together by hand for medical power supplies, and it took me at $15 an hour, which was good back in 1993. That was pretty good, but it still took me weeks of working. It took me 2 weeks just to pay for one textbook. And so you talk about these instruments and how expensive they can be. It's kind of tough to stomach. But so
Mike mentioned his TDR as a scope, and he said 20 gigahertz. Mike, I think you can get a 50 gigahertz sample head for it. I almost said sample head, but that frame will support a 50 gigahertz signal, I believe, the 803.
That's crazy.
Oh, cool. Nice collection you got there. Show us what you got.
This is just something I'm turning to, which I highly recommend. These attaché cases, you get them at Harbor Freight. They're really cheap, and you can customize the foam inside. So I've cut out a spot So it's a USB cable is for the USB logic analyzer, which is supposedly, these were touted to be able to sample up to 500 megahertz, which is absolute
Wow.
nonsense. There's no way you're ever going to get
Yeah, I was going to say, yeah.
500 megahertz with flying wires like that. You could maybe push it to 150, but for SPI and SPI bus, it's totally good enough. And this is my favorite. This is the multimeter I bought when I was first in college in 1993. First really good quality multimeter I bought back in Australia. This was branded as a Dick Smith meter, but I believe the actual manufacturer is Metex, and they just did a branding agreement with Dick Smith Electronics, which has long since turned into something I don't care for. So I've got my slot cut out for that. This meter is cool because it has this RS-232 port on the side, so I can use it as a data logger. It doesn't have a very high sample rate. It's like, probably 5 samples a second or so, but it's fine if you're just measuring change in resistance on a potentiometer or sensor, or it's got a transistor tester and a whole lot of stuff. It'll do logic probing as well. It's pretty cool. And then just recently, these are the probes for it.
How much did it cost?
Oh, this meter back in 1993 when I bought it was about $250. So, so it's pretty good. It's a pretty good quality one.
But it's still an investment for back then.
But that's the thing. So that's the point, right? You want to get. There's on one hand you can buy cheaper instruments now than you ever could, which is great, and I actually do take advantage of that. On the other hand, you also, for things like a multimeter, it's worth spending more and getting a good quality one. It's worth it because you'll keep it your whole career, and you'll drop it off ladders. Like this thing, I don't know, it's got more stories than I do about where it's been, I'm sure.
Right. And you mentioned your first meter. I've got my first meter sitting here, which is my old Simpson 260A. Actually, just a 260 maybe. And you can't drop a Simpson 260 on the ground, unfortunately, off a ladder. But my next meter, which I still have 2 to this day, and these are 30-some years old, I got to believe, are Fluke 77s. And I just swear by these things. And I have these covers for them so I can drop them off of ladders. One's a yellow cover and one's a gray cover.
Yeah,
and,
those are incredible.
Mine will disappear for a month, and I'll find it in my car or something like that from working on my car.
I was going to say that probably the worst thing that can happen to one of those Flukes is you drop it in seawater. That's about the only thing that'll kill them.
Well, I have 2 simply because I do use them all the time and they do get lost.
So I wanted to show off this. There's a lot of these also on AliExpress and eBay right now. There's FNIRSI. I don't know how you're supposed to say that. Finirsi. This is the brand. There's different brands though, but they're all made in the same factory. This is seriously 100 megahertz 2-channel 1 gig of samples a second. So this is arguably better than my Regal DS1052E, which has the firmware hack to give it 100 megahertz bandwidth.
Wow, a firmware hack.
The display on this is huge. Like, I love that. It takes up the whole thing. It's a touch screen, so it's got this cool menu. So I can go to the waveform view, and this is a stored waveform that I'm recalling from just hooking up the test at the top. So you can save and restore stuff. It's got math, so this is an FFT of that square wave.
Right.
So it's got everything you'd expect a 100 megahertz digital storage oscilloscope to have. Everything.
Cool.
And it's fully battery powered. So why is that important? well, if I'm working on power supplies, I need my scope to float. So
Yes.
I can hook the ground probe up to the drain pin on a switching MOSFET that's otherwise bouncing around off, perhaps, this is dangerous, so don't do this unless you're a confident engineer. But
well, and I'm holding my ground floater thing. I usually tear the ground pin out of my scopes, and then I keep a couple of these in the lab. There are 3 pins in and 2 pins out for the AC mains, and it's for the exact reason you mentioned. You have to float the grounds if your ground is attached to ground on your device under test.
Otherwise, you need a very expensive special isolated probe, which is another instrument that, like, you generally can get away without them, but you have to always remember that you want to measure voltage between 2 points. So you hook the ground of your oscilloscope probe to the more negative point in whatever the signal chain is, but you've got to remember that ground on the scope probe is often hooked to ground in the power supply and ground in your house or lab.
Right.
And that's a problem. And so
and the ground on a chassis that has what we call the X and Y capacitors for EMC mitigation, they form an AC voltage divider. So the ground on a typical household appliance can look like it's at 60 volts average, right? So yeah, ground is not ground; it's an opinion, and it changes.
I like that.
So does this do common mode? Speaking of grounds, can you show the difference between the two signals? So it's instead of showing signal to ground and signal to ground, you show signal to signal?
I don't know. I haven't tried it, but it does have a math menu, so I assume I can subtract one from the other, but I haven't tried it yet.
Right. I would assume so too, though, if you have a math menu.
So let me just hook something up here and see if we can see something. So I've got so this is the other subject. I've got one of the ESP dev kit C boards going. Finally, last night I spent a bit of time late at night hooking up the ESP IDF. That's the what do they call, what does IDF stand for again? It's the development framework. I don't know what I stands for there.
Yeah, I don't know. I was going to say Israeli Defense Force. I don't know.
ESP IDF is basically the C tool chain that comes with the ESP or expressive processors. So I'm hooking that up, and I've got this PWM signal. It's got measurement cursors. It's doing real-time or near real-time FFT. When that LED fades up, you can see the pulse width changing.
It means IoT development framework.
Oh, there you go. Thank you for looking that up. I did always.
Yep.
Next step will be.
I wouldn't have guessed that.
ADF.
Yeah, so, I wouldn't have guessed that.
Cool. So while I'm doing this, I could I can measure stuff. I can measure the voltage RMS, frequency, VPP. There's all this stuff I can measure here. I can save a picture. I can add measurement cursors, and I can save the waveform as well. So I do save waveform, and next time it runs, I'll do save picture, which basically is a screenshot of the whole thing, right? So now I go into menu. Here's my screenshot that I just captured.
Wow,
so I can come back, and looks like I can't measure it. It's just an actual bitmap screenshot, but that's okay. Like, this is perfect. Right. I'm going to be doing, videos and documentation for things. I need something like this that makes it super easy to just capture that and put it in a website or a document, right?
Right.
And saving the waveform, let's see, waveform view. This is the waveform I just saved. And now I can actually come back with the waveform saved and change trigger points. I can move it around, look at different times. So it's got quite a decent capture depth.
Now, does that have an HDMI output?
No, it doesn't do video, but it's just USB 2.0. So this charging port here is also a USB connection, and that's where this can be hooked into slave mode to the PC. Now,
Oh, okay.
I don't know if there's any software to drive it real time. I have to look into that. All I've seen so far is that the stored waveforms and screenshots I can get access to just as a general USB storage device. And so this is a really capable little scope, super useful, super handy to have, have it battery powered so it's isolated. I can't emphasize that enough. If you're ever working on debugging any circuit, particularly power supplies and especially switching power supplies, where you have a primary and a secondary and they must remain galvanically isolated, but you need to measure things on the primary and on the secondary, you want an isolated scope for the primary.
Right.
So you can measure voltage and current between 2 points.
Which,
and,
of course, if you had an
things out.
HDMI output or Ethernet, that would entail a ground connection again. So having a totally isolated device like that has its advantages.
Yes. And then besides that, it's almost worth getting two of these for that reason. So you have multiple channels that can be isolated. But this whole thing, you can find this on, I got this on AliExpress. This, I've got focus, you stupid phone. The 1013D. And there's a few different slight variations. And I have not compared it to a calibrated tech scope yet, or another calibrated scope to trust what it's telling me. So that's something that we need to check out. But so far it looks like it's doing its job, and that it's pretty cool. And it was brand new. It was like $130.
Wow, excellent.
Can you believe that?
That's cheaper than a Fluke used to cost. Whoops, we lost you there. So while Ben's, we've got a Skype issue again, which I'm starting to think it's the Skype servers. I've been seeing this with some other Skype. I'll go ahead and ask the channel what they thought of last week's show with Alan Wolke. That I, for one, learned just tons like I usually do anytime Alan talks. So, yep, you're coming back. We're starting to see the screen move around again.
Oh yeah, I was just saying, 130 today.
Right.
Equivalent to this, essentially. This was 400 in 2009.
Okay. So
still,
how do you like your Rigol? Do you still use it?
I love it, and I do still use it. That's why it's on the desk. It's sort of the permanent fixture. The thing about Rigol is it uses standard National Instruments drivers for controlling it through Windows.
Okay.
Plus, it's got its own programming language. Now, I haven't used it for this, but these Rigols can be. What the heck is my phone doing with focus there? These Rigols can be programmed and even issue pass-fail signals out the back. There's additional connections on the back, so they have more comprehensive factory-grade sort of capabilities.
When you say pass-fail signals, can you do masking, that type of thing?
Yes. You can actually tell it, okay, the signal, you start a test at the push of a button. If the signal goes outside of these bounds, high and low, or whatever, or outside of this envelope, fail it and issue a signal out the back that says fail. So these can be deployed and automated over USB or RS-232 in a factory situation for automated in-circuit testing purposes.
Right. Now, Rigol's had a little bit of a bumpy road from what I've heard, that it did need some software updates and things to get the accuracy out of it that you'd expect. Did you run into any of that?
No, actually, that was a marketing fumble on their or maybe they did it deliberately, actually. It's hard to know. There was a 1052E and an 1152E, and the difference was the 11. They're both 1 gigasamples a sec. The 1152E was a 100 megahertz bandwidth scope, and this says on the front panel, the 1052 is a 50 megahertz, and the only difference internally, there's no difference. The only difference is firmware.
Right.
And so some time ago it came out that you could do a firmware update and actually put the 1152E firmware in the 1052, and it would think it was an 1152. So if I turn that on, you see, look at the splash screen.
Right. And is that a violation of DRM to do that? Do you know, or is Rigel fine with that?
Rigel never stopped anyone doing it, and they never did a firmware update to lock it to 50. It's like they wanted people to discover that Easter egg. But if I go into the menu, I think there's a let's see.
Yeah, over at Hackaday, it's a favorite scope.
Yeah, it says it's an 1102E.
That's cool.
So it was super easy. Dave Jones made that popular. He didn't discover it, but he made the video that went
popular.
Viral.
All right.
So, yeah, that was pretty cool too. Because back at the time, any tech 100 megahertz scope was, well over $1,000. Of course, all the scopes have become a lot cheaper since then because of these low-cost Chinese scopes. The whole market's come around to making them much more easily accessible. So
and I've seen, I assume that the engineering was from the U.S. I thought I saw some FPGA gurus talking about their work inside of Rigel, but I can't recall their names or anything.
That may be the case. They do have quite a significant U.S. staff, and again, every trade show I go to, there's a big Rigol booth now, and they appear to be gaining a lot of traction, much to the chagrin of Tech and Ritsu and Teledyne LaCroix and who's the other big one? Agilent.
Right.
So let me just get myself organized here a little. I'm going to put this phone back on its holder so everyone can see my bill monitor, which is also my touchscreen. Let's get that back up there. And now, I don't know if it's still hard to see that display up there, but that's my Coriolis effect LED sign.
Yes.
I'm pointing the wrong side, that side. You can read it a bit clearer than you could before with the webcam.
And there's like a beat pattern between the camera lensing and the exposure and the actual update rate of the LED. You can see it going like that. It's pretty cool.
Yep. That's the Moray pattern, or it's like a Moray pattern, right?
Yeah, interference pattern, yeah.
Because of scanning.
Which I've been to Bosch and Lomb. I designed a telescope controller for them back in the 80s. Which would track sidereal or lunar, the different rates of the objects moving in the sky. And so got to see them grinding the big lenses for their big scopes and everything, and then putting it on an interference table where you could check for blemishes and whatnot.
Wow.
And to me, it's like, you're using the speed of light to use QA. That is so cool.
That is so cool. Yeah, those big telescopes are impressive too.
Yeah, I had one in my office. I used it as a sundial because I pointed it at the sun, right? And set it for the whatever rate follows the solar rate. And at one point in the day, I would have to duck under it to come in the office around 2 in the afternoon. It'd be pointed right at the door.
Would it have a burning beam of light coming out the eyepiece, cutting an arc into your room?
I didn't have that, but the lens cap was big enough you could eat dinner off of it. I mean, it was just like one of those 12-inch, 14-inch scopes or something that Bosch had lent to us.
That's cool.
Yeah.
So what are you showing us up there on your scope? You're
I just threw up some eye candy just to fill that hole. We were talking about scopes, so I just punched mine up, but I don't have a signal going to it. I just happen to punch it for FFT, and on mine you can select the different FFT modes and stuff.
Do you also use a USB logic analyzer? What do you do for your logic analyzer?
So the one that I'm currently using is the...
Oh yeah, that's right. That's right.
And then somewhere I've got my older... Let's see if I have my Selig. Ah.
So one of the things...
I lived off these for quite a while. These USB... those things rock awesome. For the age of them.
So easy. So easy.
Yes.
Now,
and I've talked to the owner of the company, the founder of the company. We had a great talk about how to teach software to kids and stuff. It was, a matter of fact, so to do two of them, you just plug in a second one to add to the channels, and you can integrate a certain number of channels in the software. So the fact these were small, was okay back in the day, but nowadays, that was the one I went with.
The software that comes with those, did it have some basic protocol analyzers like the SPI and I2C, like we were talking about?
I can't remember, but but I want to say yes, but I can't remember for sure.
Yeah, that's a super valuable thing to have, is a logic analyzer with some basic protocol analysis that'll tell you, okay, this is your start or preamble, this is your address, this is the address that it's sending, so you can make sure you're sending the right address in your firmware.
Right.
This is the acknowledge, and now here's the data stream. And I've troubleshooted so many things, because just about every chip-to-chip connection nowadays on a small design is going to be one of those protocols, SPI, I2C, or even a basic parallel interface with some handshaking signals, right? I would say, next to an oscilloscope, if you're getting into electronics and starting your career in electronics, the next thing you need is a logic analyzer. And then the third thing is, if you can afford it, probably a VNA, but only if you absolutely sure you're going to be doing different things with RF.
Yeah. I went for years and years and years without a VNA, and it shows. I made mistakes along the days.
It's so expensive, right?
Right. Right.
Again, like other instruments, there's some USB VNAs they're still more pricey than scopes, because they have very difficult things to get them to work accurately. But yeah. So.
What else do you have as far as equipment? I'm going to show one of mine here, but it'll take a second for me to punch it up. Whoop.
Well, obviously you need power supplies too.
What kind of power supply do you use?
I have a couple. I got an analog bench supply, but it's in my shed right now. It's not in the office. And the reason you need... Okay, so for years I got by just making my own power supplies with basic wall-wart adapters and voltage regulators.
Same here. I use 3-terminal. I go back to the LM309K, right?
Yeah. So on the breadboard, I always have an LM3. I have always a LM7805 or something equivalent to that to give me a regulated 5 volts. And you can fool around with stuff like this, which is a switching regulator that gives you pretty high current 5 volt output from whatever you feed into it. But the thing about a proper lab supply, the thing that sets a lab supply apart from the fact that it has a variable voltage, they all have current limiting. So,
right.
So you at least need a bench power supply that has those two basic functions. You want it to be able to go up at least to 30 volts if you can, because a lot of stuff that you would design in the analog world needs plus and minus 15. So you can have a 30 volt single supply and use a voltage divider to give a virtual ground to give you a good regulated plus minus 15 for driving op amps. But also most of them probably go up to about 2 amps typically. If you're doing power amplifier design, you need more current than that. And but you definitely need current limiting. You want to be able to set the current limit to say, if I've screwed something up in my prototype or what I've put on the breadboard here, and I've got something reversed, it's going to short out, or maybe short out if you have a chip around the wrong way. Like, everyone makes those mistakes. Let's not be fool ourselves.
Oh, I put a diode on any design I do. I put a reverse diode, and Mike can attest to this, that I think he got back to me and said, your diode just saved the day on something.
Yep. Reverse, that's another thing. Always design protection into your products, and unless it's like super quick and dirty and it's simple enough to really know what you're doing. But
yeah, you don't mind screwing up, then you can forego the diode. But I usually, my time's too valuable these days to blow up everything I'm working on and start over.
But that's the whole point of the power supply, right? They have a current limit set. You short them out. You deliberately plug your shorting lead across the terminals, and you dial up the current to say, what's the maximum current I'm going to have allowed? And you can make it 2 amps, you can make it 1 amp, you can make it 100 milliamps. Then you unplug that, the voltage springs back up to the regulated voltage, the current needle drops down. But what it means is, as soon as you plug it into the breadboard, if you've screwed something up, the voltage drops and the current needle goes up, and you quickly disconnect.
You can troubleshoot with it. You can sit there and dial in the current and go, I was expecting 200 mil. Why am I pulling 400 mil? But you can do it by current limiting and see, keep coming up on the current till suddenly, like you said, the voltage comes back. And
that has saved many an explosion, or the black smoke, magical smoke coming out of power transistors on power amplifiers and power supply designs I've been working on over the years. It stopped capacitors blowing up in my face.
You know what it stopped for me blowing up on those old amplifiers was cooking the emitter resistor. Remember, they'd have like a 0.33 ohm resistor, 0.47, right? And that's so they can develop a voltage across it, but not get in the way of the current. So it'd be like a 20 watt 0.33 ohm resistor, and you would cook it if you had a short in your output.
That's right. And the other reason they had those resistors was if you need to parallel multiple.
Yeah, you got to give it something to drop voltage across. Yes.
So because the emitter resistance in bipolar transistors depends on the exact way they dice the silicon, and they're not all exactly the same, so they won't share current equally. You can't just parallel transistors up for higher current.
You can't parallel LEDs either. You need some little resistance for some right, because one will be 1.25 volts, the next one will be 1.255 volts. And that 0.005 has to go somewhere in the form of heat, or 0.05 or whatnot.
Yeah, or one will be brighter than the other. Yeah.
Yeah, it'll steal from each other. It will not current balance. 2 LEDs in parallel is a good assumption to make.
Yeah.
So. Now, I'm showing up in the top right corner here. I grabbed the image off the internet, but that's the function generator. I've had one of these in one form or another since the 80s. This is off of eBay, and I still swear by mine. This is my go-to generator.
That is a beautiful instrument.
And there's an Easter egg embedded in it. I just don't recall what it is, but somebody had seen it on my bench in a Hackaday video and said, my dad did the code for that. There's an Easter egg at something. I wish I knew what the code was for it.
Yeah, those are really great instruments. And again, if you wanted to buy something new instead of used but save money, you could get one of these. These are about 80 or $100. Again, they're not anywhere near as high quality output signal as, say, an HP or Agilent like yours, Bill. But this is a great DDS function generator with 2 channels, and it has input for modulation, and you can actually it has inbuilt modulation. You can do frequency shift keying, amplitude shift keying, phase shift keying, bursts, AM, FM, phase modulation. So it's actually pretty full on.
Yeah, that actually does more than mine. Yeah.
And it also has a USB port and some control software. Again, like the Rigol, it uses the National Instruments protocol over USB to communicate with it, but it's got this dinky app that's not very well written, has a bad user interface, but it means you don't have to use all this front panel.
Right.
So you can preset some more complex waveforms.
Arbitrary function generator. Is there an AFG built into that?
Yes. So I could actually load even wave data, I think, from a CSV file, and have
right.
I could generate something using some weird thing. So maybe I could open GNU Octave and just write a little script to generate wave points for a particular type of modulation, like QPSK or.
Well, I was going to say you can have thousands of points,
week, right?
and simulate an entire encoding scheme with an arbitrary waveform generator.
And it's got pretty good bit. It's 14-bit, which a lot of the early DDS generators and even the cheaper ones you get now, a lot of them are only 8-bit. This is 14, and 250 megasamples a second. So it's not really getting you into the RF, but it is. I haven't tried it yet, but I think it'll easily output up around 100 megahertz.
Right. So somebody asked, what is DDS?
Oh, that's a great question. And now I'm brain farting on it. Direct digital synthesis, I believe.
That's right. Yeah. Yeah, Chris just posted that as well, and
yeah,
I was trying to think of the DRAM is a protocol.
And just so everyone, just for those who are getting into all of this and RF as well, DDS is the fundamental building block for software-defined radio, because you want to generate the output directly from a microcontroller or high-speed digital signal processor or FPGA for a fully modulated RF waveform. So if you're transmitting, oh, dude, is there anything you have not discussed on Hackaday?
That's why it's hard to make videos. It's like, well, I've already said everything I know. Now I'd have to make stuff up to do it.
No, just say it again.
Yeah, if they'd let me. But yeah,
wait,
I show.
Go up, scroll back up. So you're talking about the DAC there. That's cool. But what's this? This is some FPGA. It's the Altera FPGA design software. That schematic. Is that
yes. So I did a whole DDS thing in using an FPGA to drive the R2R ladder. And so I kind of show all of those.
Yep. Now here's the thing. The R2R ladder, if you're going really fast, there's probably enough parasitics in the signal chain
to act as a cap, yeah,
to smooth out the waveform so you don't get the tiny little stair steps with each sample. But if you're wanting to sample audio frequencies or really anything under 100 megahertz, you really need some kind of filtering, analog filtering on the output called anti-aliasing. So that means you take out the discrete sample time or sampling frequency artifacts, and so you'll, in software-defined radio analog front-end chips like the Lime microsystems, they have things like that. They have not only the DDS and the synthesis and the DAC, a high-speed digital to analog converter. After that, they have digitally programmable filters for low pass to smooth out waveform.
Right. Mike and I just played with the triangle generator I was using it for frequency modulated continuous wave radar. And so he got in there and played with cap values till he saw a nice smoothed in triangle versus the little steps. In my mind, when I see the little steps, I get this submenu in my head of the mathematic implications of the quantization error, right? And when I was younger, I actually understood the value. Now it just pops up in my head and I can't do the math anymore.
Well, that's also important if you're, okay, so here's just something, food for thought, right? That's also important if you're designing what's meant to be some sort of consumer product. You have to comply to FCC regulations for interference.
Right.
And Mike is a good case in point because he spends a lot of his time. He got into electronics by having to get things to comply, which meant he had to measure them. And so he started learning about all these instruments and acquiring them and stuff. If you have a sampling frequency of, let's say, 250 megasamples a second, that is a fundamental transmission from whatever your device is. And your whole circuit's got that. Your whole circuit has that as a signal in it that's potentially going to radiate if you just don't design your board well enough. And if you don't have an anti-aliasing filter, and that gets into something else that amplifies it or makes it worse, suddenly you have a spike of spurious emission that you're not allowed to have. So, so you have to pay attention to these things is all I'm saying. You got to, if you have...
You're right.
Anything,
in my mind,
anything analog from a digital source, you need to make sure you filter it, or it's got the filters built into the chip you're using, which a lot of the time they do. Yeah.
Right. So we were going to actually show near-field probes, but that's probably left for a different day and a different conversation. Yeah,
we're out of time for that. The group really was getting curious about crimpers somehow. So you've got your ratchet.
Here's my go-to crimper. I had to go to the garage to get this because, again, I do a lot of work on my car and whatnot. So this is all, basically, I have a ratcheting crimp tool. And yes, I've got my finger stuck in this where you have to keep closing it before it'll open again. Yeah. And yes, it hurts. But I can change the heads on this depending on, let's see if I find a good camera here. I can swap out the head on this for various types of crimps. And you can see the color code for the sizes. So with this one crimp tool, I can do just, well, you see all the various heads I have for it. So, I don't even know the brand of this, but this one is a...
You can do spade lugs, you can do... So the best crimp tool I have is looks almost identical to that, but I don't have any other attachment.
Right, and I have one of those too. This is for the common spade lugs that you'll see. And, you know, one of the things I mentioned is there's art in crimping. And part of that's knowing how long to tear off the insulation. Part of a crimp is meant to grab the insulation and part's meant to grab the metal. Stripping too far back and they're both grabbing metals, not stripping enough and they're both grabbing the insulation. So, you know, in production, we had big crimp machines, big amp crimp machines, and the wires were definitely stripped to a known value before we used them.
Yeah.
So, but I've got other crimpers.
But even handheld crimpers,
you can make a good crimp with a good crimper. Yeah.
The ones manufactured by the connector manufacturer for their connectors.
That's it.
I used to wonder, like, why are these so expensive? Because some of them were hundreds of dollars.
Hundreds. And the heads alone are $300 just for the set of die that go in here. I should have been calling them die all this time.
But they are... But you don't have to, like, just for a general purpose use, you don't have to go so nuts. But
so what do you think this one was used for? That's a hexagon in there, in two sizes. Whoops, I lost you. So this is how I crimped coax cable in the old days, RJ58 cables, RJ8s. And then I also have, you're frozen. I have a Ethernet crimp.
Yep.
Okay, you're back.
That's the one.
Nope, you're gone.
That's the main good one I have is for RJ45s, just like that one.
And then I have one of these, and yes, it looks like a bolt cutter. And again, because I do automotive, you know, for my own car, but I've done, you know, 1 gauge and 2 gauge wires. You actually dial in the thickness that you want here. There's a little scale on the side. And then you lean into this thing. I know people that say they use hammers and stuff to close those copper ferrules and stuff. No. And if you can't do this, go to an automotive shop that can do this. You know, because the thing is, with a 1 gauge wire or 0 gauge wire, that cable's capable of 50 amps. You don't want that cable coming out at any time. So get a good crimper is my advice when you do this. And
it's
if somebody's in the area and needs something crimped, come on by, you know?
There's I didn't realize this starting out in the industry, but when I mentioned earlier, my first job was at a power supply factory soldering together boards for power supplies, medical power supplies. They had a technician there who did all their repairs. Every product they sold had a 5-year manufacturer's warranty, so things would come back.
Right.
And some of them had wire harnesses coming out of them, and some of them were just, had screw terminals and whatever. Yeah, the whole gamut. I remember one day.
We lost you again. Hang on. Hang on. We lost you. I wanted to hear the story too. That bites. So actually, Wes is asking about wire wrap, and I don't know if I'd call it a weld. Maybe somebody knows better, but the wire wrap would actually cut into the wire on the post and create a I don't want to say an amalgamated connection, but yes, it would cut through the oxide on both the post and the wire and form a good connection. You're back. We can see it. Tell us the story.
I know. This is so frustrating. The story was I soldered a crimped connector once, and the technician was looking over my shoulder.
He got on you, didn't he?
He said, "Don't do that."
No.
Why?
Right.
Why? I'm making it better, lower resistance. It's like, no, you don't understand the metallurgy.
You're making it brittle. Yeah. And that's an important thing. The if you solder it, now it's brittle. Is the way it was explained to me. Whereas the people at AMP and Amphenol and those, they knew what they were doing when they designed the way that crimp grabs that wire. It's meant to have a certain amount of force into those those different conductors.
And that also counts for terminal blocks. So a lot of boards have these little Phoenix contact style terminal blocks, like this blue one here, right?
Right.
Those are designed for untinned copper, multi-stranded copper wire. And
right.
If you can put tinned copper wire in it, but it will eventually work its way loose because it's tinned.
Yeah. Alan's joined us, and he called it a gas-tight connection.
Yeah, that's it. If you don't tin the wire, if you resist the urge to tin your wires, and you put them in there and you clamp it down, they'll stay there happy till the cows come home. Or longer.
Done correctly, they stop being. They're still a failure vector, but they're not a significant one done correctly. And we've had an AMP troubleshooter come in. They used to have a truck come by where I worked at Pennsylvania Scale Company in Lancaster County, Pennsylvania, and they would come by and show us their newest things. It's like a big RV, and we've had them come into production and troubleshoot if our failure rates go up, and have them tell us what's going on. So you're freezing up again, but it's coming up on the top of the hour. I don't know if I'll get you back. You're starting to move a little bit again. What's this? Chris saying you have a stress point where you move from soft copper to tin. Yeah. We could talk about vibration modulus domains too. All right. You're moving like an old time movie. So let's go ahead and call it done here. We're coming up at the top of the hour. I don't know if Ben will come back, but it was great seeing everybody again, talking with them. Alan, we did talk about you at the beginning of the show, of how good a show we had last week. Ben, you're back. Any last things to say?
Oh my gosh, I'm just so frustrated. I did an internet speed test and it still tells me I had 7 megabit upload, so I don't know what's going on here. It's just Skype or something. It's super frustrating.
Yeah, and like I said, Skype has been acting up this week, in my humble opinion. I've been Skyping with other people who've been freezing, and they had plenty of bandwidth.
So that's I've got bandwidth. That bandwidth is not the problem. I'm just thinking we might need to find an alternative, which we keep talking about, but not actually doing. Because once you get something to actually just work, you kind of
and Alan and I did a. I tried to record one, and we tried to use, what was it? It wasn't Skype, it was the other one.
Zoom.
A Zoom, and of all things, my audio didn't record to disc. Everything recorded but audio to the disc. So there was 2 audio buses going on. It wasn't on the right audio, and we wasted a whole show. So the thing we do with Skype that makes it unusual is it's called NDI, and that's how I can easily integrate into my XSplit that you see us talking on. I use the screen share as an NDI source and you as an NDI source. So it's hard to find a replacement for that.
It is, but there's bound to be, because we're not the only
somebody saying Discord, WebEx.
No, I've got a bad taste in my mouth about WebEx, but that's a whole other story.
And I don't know that Discord. I asked the question, how do you get Discord into a program like XSplit, and I never did hear an answer from that.
Yeah, so. I'm sure that's not currently possible, but we'll find a way. We at the very least could create. Technically, we could set up a VPN between me and you. And then do a direct, use XSplit. I could transmit XSplit to you, and you could
use an NDI.
Take that as an NDI stream, or And we actually started our live stream, kind of doing it, I think, that way, or maybe it was in reverse. But
so people are asking about OBS. OBS would replace XSplit as the switcher. But we would still need a protocol to travel between us, which would still be NDI or RTMP or something.
Yeah.
Yeah.
So I'm thinking, Bill, and this is probably not possible given your business situation, but if there were any way we could have a VPN hooked up between us, RTMP might be the way.
We have to be careful about that. Yeah, but there's ways. I'm a security guy. There's ways to do it. So excellent. All right, my friend. Good seeing you again. It was wonderful talking with you. It was fun pulling out my big crimper. I don't get to do that very often, but
and now we all have crimp envy.
Well, like I said, if somebody's in the area, or you can even mail it to me, and I'll crimp it and send it back. So excellent. So we'll see everybody next week, and everybody have a safe weekend.
And come back next week and stay tuned, because we want to talk about a giveaway or something like that. We want to grow the audience, and I have some stuff that is really cool, but I don't have space for, and I know, like, here's just the Bryman EEV blog multimeter is one of those things, right? So
okay.
Brand new in its container,